Okay, this is going to be the video from Chapter 7 for tides, just for tides. And tidal range. Tidal range is really just the difference between your high tide and your low tide. Subtraction. Okay, from your Topic Sport Guide Learning Outcome E. There you go. Okay, it says describe how tides are produced and how the alignment of the moon and sun with Earth, coastal geomorphology, or what the shape of your coastline is, wind, and then air pressure, how it could affect your tidal range, the difference between high and lows. Okay. What causes it? It's the sea level change, the tidal change in water that's caused by the gravitational pull of the moon and the sun on Earth. Gravitational pull of the Earth, gravitational pull on the Earth from the moon and from the sun. There are, in most places, 2 tides a day, which is what we would call diurnal, semi-diurnal, 2 tides a day. So 2 highs and then 2 lows. And that's because of the moon still kind of being in the sky in the morning and then setting, and then the moon coming back up at night and then setting again. Okay. Diurnal is just 1 high, 1 low, and typically those are going to be in like smaller bodies of water. Really large lakes, Gulf of Mexico, Mediterranean Sea, just smaller bodies of water. It's hard to see it in a lake, seeing tidal effect in a lake because of the wind. It kind of like cancels it out, but okay. So this is the cause is by the gravitational pull of the sun and moon on Earth. And then depending on what their orientation is, it will cause either to have a really big tidal range or a smaller tidal range. Okay, reading below that now. It says the tidal amplitude, which is the height, will be different when the Earth, moon, and sun are aligned together or in like 180 degrees straight across in a line. Your tidal range, the difference between high tide and the difference between low tide, is going to be the greatest because you have the biggest pull on the Earth and the water on the Earth. Those are called spring tides. It has nothing to do with spring, but it's called a spring tide. And so I just think like boing, like a spring. And like that's going to produce a really big distance. The high tides are really high. The low tides are really low. And so the distance in between is going to be great, the difference. And then this occurs when the moon is either full or there's a new moon. Right now we have a full moon and it's April 26, 2021. We have a full moon, and so I know that we're having some spring tides. It's very bright. However, if the moon and the sun are at like 90-degree angles from the Earth, you'll have neap tides, just little neap ones, just small ones. And instead now, like the moon is still going to pull toward on the Earth, but then the sun's also pulling as well. The moon has a greater gravitational pull. The moon actually kind of it has a bigger say in it, but the sun is so close. I'm sorry, the sun is so large. I'm losing my mind. The sun is so large, it also will have, I guess you would call it a solar tide on Earth. The moon is just really close. And so that's why the moon is able to have such a pull, even though it's nowhere near as big as the sun. And so neap tides, it's a neap tide whenever the high tides aren't that high and your low tides aren't that low. And so the difference in between is going to be pretty small. High tide, that's a spring tide. A low tide is very low on a spring tide, and the difference is great. On a neap tide, when the Earth, moon, and sun are like perpendicular to each other or at 90-degree angles, then you're going to have a neap tide. The highs aren't that high, and your lows aren't that low. And so the range, the difference in between, is not that great. And then just to visually see, when the tide is high, like the water is like able to come onto shore closer. That's when the tide starts getting high, or we'll be like, oh, the tide's coming back in. That means that we're probably going to move our towels back further. Because it's almost like the moon, if we're looking at the diurnal one at that high tide area, the moon just is not pulling as great. So, and the moon is like on another, it's on another area of the planet at that time. So the pull isn't as great. And it kind of like releases that pull, and all that water is able to flow back. And then the moon starts to come back again, and it pulls the water out. Semi-diurnal, these are 2 times a day, and these are going to be like what the oceans experience. Low tide, low tide. And that's when the earth is getting pulled on the most by the moon and the sun. High tide, high tide. Even though the sun is out, the moon is gone. And that's why we start to see it look so high. Like lets that water go. I just kind of sketched this out just so you could see a visual. So this red line is your average sea level. That's like the normal. What the Neap, the little ones, the little tides, what the Neap tides actually encompass is this light blue area. So if the average sea level is this red line, on a low tide, when it's a Neap tide, if your Earth, Moon, and Sun are at 90-degree angles from each other, or they're perpendicular, the pull is not going to be as great, the gravitational pull. So the low tides aren't really going to be that low, and that's why I said it's higher low tide. It's higher up than a normal low tide. And so if the pull on the water isn't as great, then when it releases it, it's not going to be that great either. So there's the right above here, this light blue column. It says lower high tide. It's a lower than normal high tide. Oh gosh. All right. And then your spring tides, they have the biggest tidal range, the biggest difference in high tide from low tide height. The spring tide is this darker blue line, and it goes all the way up here. And there's a high tide. And if we look down, there's our lower low tide. So the spring tide would really be like the tidal range for that is the difference between this dark blue low tide line and the top dark blue high tide line. Versus on your Neap tide, the water level is only going to change a little bit. Just a little bit, just this light blue area. And that is not that big of a range. All right, and then this is the picture it's on there. So if we're looking at this picture, here's our little moon, and we see that the Earth, the moon, and the sun are in a line together. So what the Earth actually would be seeing here, I believe we would see a new moon. Wouldn't be full. And everything with mass exerts a gravitational pull on everything. Well, the Earth gets pull. I'll start with water. The water right here, where my cursor's at, and I'll change my pen. Okay. The water on this side, water is not screwed down, held down, glued down, nailed down, attached to nothing. Water is not attached to Earth at all. The only reason water is on Earth is because it has density, and Earth has gravity. Like at the center of its core is where everything's kind of like pointing towards that center mass. And so because the water is not stuck on Earth, it can get pulled this direction. We have our moon, You also have the sun right here. It can get pulled that way. Well, listen up. The second tidal bulge, and that's what they're called, tidal bulges, on the other side of Earth, over here, and I'll do this one in yellow. This one, that tidal bulge, there's nothing pulling on it over here on the left side. So where it's coming from is the Earth itself, like the entire planet, is pulled on by the gravity of the moon and the sun. And so that moves the planet over. And because water is not screwed down, held down, nailed down, fixed to, attached in any way, it is not attached to the Earth. It's almost like over here on the left side, the Earth like leaves it. Like the Earth like moves away from the water. And that's because the water over here is not getting pulled on. The water is not attached to Earth. So that's why you get the second tidal bulge, because the gravity is pulling on the oceans that are on that side and the Earth, the planet itself. And so the planet gets pulled over, and it's almost like it's leaving this water behind. These little things right here where I have FG with an arrow, FG, that's just, that's how you would write it in like physics if you were showing gravity. So FG is the force of gravity, FG. And so I put the force of gravity from the sun and moon pull on Earth and the water. Water is not attached to the Earth, so it will move too. So Earth gets pulled, leaves some water behind on the left side, and then the water on the right side itself also gets pulled. Come on. This is frustrating. It's a good time. I would like to erase this. Oh my gosh! Why would I go on every slide? Sorry. Okay. Try and move that again. Dang! Okay. Okay. So there are two different tides. Spring tide is caused when the Earth, Moon, and Sun are in alignment together. They're at a 180 degree. This ends up being when we have a full moon or a new moon. This makes the tidal range the greatest, and that's the difference between high and low tide. A neap tide is caused when the Earth, Moon, and Sun are at a 90-degree angle or perpendicular together. And this is during a quarter moon or crescent moons. And this causes the tidal range to be very small because the high tides aren't that high, the low tides aren't that low. And if you subtract a low number from an even lower number, you're not going to get that big of one. Okay, and so at the bottom, this is where it says, how can wind, the shape of the coastline, air pressure, and the size of water affect your tidal range? So how far it goes. So tidal range, and that's this bottom part, or tidal amplitude, its height, is subtracting the difference between your low water and high water. This will vary considerably in different parts of the world. The nature of the coast, talking about like what is the shape of it like, including the slope, very flat coastlines where water can spread out, do not have as obvious tidal changes, kind of like ours. But if you have a very like narrow coastline and it's not very spread out, might have a lot of height. Like if there's rocks there, you'll see the water fill up a lot. And I'll show you an example of that. The size of the body of water, obviously, smaller bodies of water don't really show a tide. And the weather conditions, how that can affect it. And remember, the rocky shores actually have more of a stable environment because the rocks don't let water like flow through it. The rocks can pool the water, creating little tide pools or rock pools. This allows organisms to stay moist and not desiccate. This also will help reoxygenate the water when the tides come in and out. This will also help remove waste. It will help stabilize the temperature, stabilize the salinity, and it will also help move around sperm and egg if an animal were to deposit its sperm and egg in the water. The reason why with temperature, high tides can be higher, something that happens in, I can really just exemplify this the best. If you have like a gas or anything that gets too hot, it could pop. Like a balloon, if it gets too full, it could pop. That's because when things get really warm, they expand. So if we're even talking about liquids, liquids that get really warm, those can also pop, and that's called thermal. Not pop. What am I saying? They can also expand. But that's called thermal expansion. And so that can definitely happen when things get pretty warm. The water itself will like kind of also swell. This has the example of the shoreline shape. And if we notice their coastline too, what is that? Anyways, if we're noticing the coastline too, like that coastline is very, very narrow. There's a lot of little like entrances into it. And that's going to really show the water level much higher. And something to notice too has something to do with what we're talking about though. Well, same thing I said with the water is not attached to Earth. Well, neither's the air. And so I'm gonna go back like 10 seconds and I like watch the atmosphere circle around the Earth and it's not stuck on the Earth. Come on, trash. Start it over. It should be right now. And it also moves independently of the Earth. This is where I said the Earth gets pulled over. Okay. This is on your Google Classroom, just a little bit of practice about tides. Just good practice. Save my answers here. Tides are caused by the gravitational pull of the moon and the sun. The moon is closer to Earth. It has a stronger pull. What happens when they're in line with each other? There's a stronger gravitational pull. This will cause a spring tide. There will be a really big tidal range. Spring tide is caused by a strong gravitational pull of the moon and sun when they're in alignment with Earth. Spring tide has a very large tidal range. What position would your Earth, moon, and sun need to be to cause a spring tide? Be 180 degrees of each other, or you could say in a straight line. Explain a neap tide. A neap tide is when the Earth, moon, and sun are at 90-degree angles from each other, or perpendicular. So it's like the pull of the sun is great. Gravitational pull of the sun is great. But then when the moon is on the other side of the north or south pole of the planet, it's going to be pulling up a little bit too. It's going to be pulling on that side of the planet while the sun's pulling on the left side of the planet. And I'm talking about the picture that I have drawn. That's just going to kind of cause them to cancel each other out. They're not pulling in the same direction. They're working against each other. Here's just a quick practice on calculating tidal range. You do not need to graph any of this. It's literally just subtraction. And so to do it, you need to do the high tide minus the low tide. And so yellow subtracted from what's in green. Let's move that again. So annoying. Oh my gosh, why? Okay. So here's the answers. So, and I showed you what I did on the side too, to subtract them. So 0.59 minus 0.46 is 0.13. So the range is 0.13 meters or 13 centimeters. And that's the difference between high tide and low tide. And then I'm pointing to June 6th because I made a mistake. 0.98 minus a negative, which is really plus a positive. 0.23, 23 minus 2 should be 1.21. It should be 1.21. Anyways, but excuse me, once I had all these done, I was able to kind of look at it and see, okay, where you're getting around June 6th up to June 13th. These are going to be pretty big tides. These have a pretty big tidal range. That's why I know that it's going to be a pretty big tide. Your biggest one, your spring tide, is June 9th. And then it starts to decline again. All right, so what can affect it? The shape of the coastline. When a tide enters a narrowing river mouth, or the Bay of Fundy, I wrote it over here, the height of the tide is increased, it's really big, just because it has a small, narrow passageway to go through. Changes in wind. I'm going to yawn. Hold on. Okay. Changes in wind. So this makes sense, though. If you have onshore winds that are blowing towards your shore or on the shore, that's also going to help push the tides. It will make the tidal range even higher than it needs to be because you're having such an extra push of water onto the shore. If you have an offshore wind or something that could help cause upwelling, that wind pushing the water offshore is kind of like a counterbalance to the tides, and it'll actually make the tidal range look a little bit smaller because the water just wasn't able to come up as much as it normally would because of those winds. Okay. Right, so changes in wind or air pressure can have a significant effect on tidal range. A strong onshore wind, okay, or low atmospheric pressure, that happens during a cyclone. I'm sorry. That happens during a cyclone, hurricane, typhoon. And where the eye of the hurricane is where the air pressure is the lowest because it's experiencing the most amount of like rapid evaporation. And so all that air is moving up, creating like this area of low air pressure because it's can't see this happen, but because there's no air pressure on the water can also expand a little bit. So if it's really warm, you have thermal expansion. And then if you also have like a hurricane going on, just because the pressure, the air pressure that's pushing the water down is not there. So the water doesn't have to get pushed down as much, it can expand. When that happens, and I believe this was like a Hurricane Katrina situation, when that happens, you're going to have extremely high flooding. Oh my gosh. And really strong storm surges because, again, you have really high tidal ranges, so spring tide. And then you have low atmospheric pressure where the tropical cyclone is. So now it can expand that way. And if you have a cyclone, then you know that the water temperature is at least 26.5 degrees Celsius or almost 80 degrees. So then thermal expansion can happen and that water can also expand. It can make the water level really, really high. And this bottom one, the size of the body of water. In oceans, the tidal amplitude or tidal height is really high as it enters like your continental shelf, the continental margin, when it starts to come onto the continent. But the lowest tidal amplitude would be really small bodies of water like Mediterranean Sea. Gosh, why am I yawning so much? Or the Baltic Sea. Large lakes can experience tides, but it's just hard to see. Sick of moving this cursor around. It's a Bay of Fundy time lapse. Now the moon's going to start coming back out. It's going to be evening time. The sun will set. The moon's pulling back on the water again. Here's another one. And these are all just like the shorelines, shape of the shorelines. Rocky shore. Doesn't look like it's experiencing much wave action, so I imagine you got a lot of sedimentation happening on the shore, on the bottom of it, but aside from the tides. There we go. Okay, print this out from Google Classroom, unless I gave it to you in class. Explain how the alignment of the sun, moon, and earth affect the tidal range. So how will tidal range change depending on the alignment of the earth, moon, and sun? So in a spring tide, you have really big highs and very low lows. So the difference between that is going to be large. And this is when the earth, moon, and sun are aligned together, and the earth is pulled on, and so is the water. So is the water. The earth is just pulled on from the gravity of the moon and the sun. The earth just gets pulled on more on the side where it's closest to the moon. This will be during a new moon or a full moon. These are at 180 degrees or in a straight line together. Your tidal range is really high. For a neap tide to occur, the moon needs to be either on, the opposite side of the, not the opposite side of the sun, but perpendicular to the sun, or a 90-degree angle. Because the sun will pull, because the sun is huge. The moon will also pull on earth and water because it's really close. So they kind of cancel each other out. This is during a quarter moon or a crescent moon. Your tidal range is very low. Okay, this is the last slide, and this is the test question. You guys, it's like my cursor's moving too fast. Okay, so go for definition on here. Tidal range, it's going to be the difference in high and low tides. Measure in meters. Difference between high and low tides. Okay, so now explain how the earth, moon, and sun being in different alignment could affect tidal range, the differences. With tides as well, while I'm thinking about it, this is something you could also draw on the test and get some marks for like an annotated drawing. So if you did a picture like I did, I think you would be able to get all those marks. Okay, so I write the answer from this question, essentially. But for a spring tide, this is when the earth, moon, and sun are in line together, or they're at a 180-degree angle. And this is during a new moon or a full moon. The tidal range is the greatest, and this is a spring tide. When the earth, moon, and sun are perpendicular or at 90 degrees from each other, this is a crescent or a quarter moon, and you just need to have one of those. The tidal range is the lowest. This is a neap tide, just a little neap. And then the sun will exert a solar tide on Earth, and that's going to kind of like partially cancel out what the moon is doing. And these are your tidal questions. This is like oh my gosh, the biggest tide question. I think it's 6 marks. Either way, there are many other tide questions that I gave you, and they can also be practiced. You have the answer key for that study guide questions, but this is the one that I really needed to explain out. Okie doke, y'all! Whoop, whoop. You got all your chapter 7.